atoms are kept together. Just to finish this off, and this is going to form the basis of your homework, I just want to confirm another electronic configuration, because we could have a third shell. And I'm going to get rid of all these, and I'm going to build another atom for you so you can get it from scratch. So here we want to build an atom which shows you again how those electrons are arranged in a bigger atom. So why don't we go oxygen? Oxygen has a big number of 16 and a small number of 8. That means it's got 8 protons, the small number, and, we'll put a minus sign here, 16 minus 8 neutrons. Now, in all of the atoms that we've talked about, there have been the same number of neutrons as protons. Don't make that mistake, okay? Sodium, Na, has 23 as a big number and 11 as the small number. So can you see that's 11 protons, but 23 minus 11 is 12, so 12 neutrons. And in fact, let's take sodium. Let's not take oxygen, because sodium is even bigger, and we can see how this is arranged, because I would like to go into the third shell, actually. So, 23, 11. Can you think how many protons sodium's got with the small number as 11? Good, 11. So we are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. How many neutrons? Big number minus small number, 12. So, 1, 2, 3, 4, 5, 6, so that's 7, 8, 9, 10, 11, 12. 11, 23, 11 protons, and 23 minus 11, 12 neutrons. Okay, so there's our nucleus. Remember, this nucleus is sending out a positive charge because the protons are positive. So now we have to think about electrons. Well, the electron number in an atom is the same number as the protons. So do you remember, in our first layer, which we call a shell, and I'm going to stop saying layer now, in our first electron shell, we have 2. Then, that one's actually become full. In our next layer, we can have a maximum of 8. And they actually sit together in pairs when you've got 8. So we have 1, 1, 2, 1, 2, 1, 2, and 1, 2. So let's just count how many electrons we've got so far. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need 11 because it's the same number as protons. So we've got one more, and this one goes in the last shell. And so we would write the electronic configuration of sodium as 2 in the first shell, 8 in the second, and 1 in the third. So sodium has an electronic configuration of 2, 8, 1. Now I'm just going to finish off by saying that that is the way that you can work out how atoms are made in terms of their makeup of electrons in any atom. As long as you've got the small number and the big number, you can work out how many protons it's got, how many neutrons it's got, and because the number of electrons is the same as the number of protons, how many electrons it's got. And because you know that electrons are arranged as 2 in the first, 8 in the second, and actually it's a maximum of 8 in the third, then you can actually work out where the electrons go of up to 2, 10, 18 electrons. And the prep I'm sending you is for you to actually draw these. Use this video and see if you can, and it's quite tough actually because this is the only time I've taught you this, but see if you can use this video to see if you can fill in the electronic configurations of the atoms that are listed in the prep. Okay. Last thing. I have said a number of times that you can tell that the numbers of electrons equals the number of protons in an atom. Well, the reason is that an atom has no charge, no overall charge. And if there's no overall charge, then the pluses must equal the minuses. So in sodium, if we have 11 protons, which are 11 pluses, then we must have 11 minuses. And that's how we know that the number of protons is the same as the number of electrons. We do meet later on an atom that's been changed and will have a charge, which we call an ion. But for these purposes, as soon as you have an atom from the periodic table, the big number will be the protons plus neutrons, the small number will be the protons alone, and that will also equal the number of electrons because the protons and electrons must cancel each other out in terms of creating no charge. The pluses and minuses must be equal. So I hope that that is not too confusing. I hope you understand the way that atoms are put together, the particles involved, the numbers, the big number and the small number, and how electrons are arranged. See if you can do that prep, and we can go through it next lesson.